Greetings, statistics buffs. It's time to review another problem from your favorite class, elementary statistics. We'll be looking at the further problem 3 on page 346, in particular part A for this first clip. And this is, of course, from chapter 13. We'll be looking at making a point estimate of some data. So let's look at our solutions. The problem type is a point estimate. Part B will make a estimate by interval. Point estimate. Point estimate of what, Meyer? Point estimate of the difference in population means. Of two populations we're going to make this estimate from the means of the two samples. The samples are, if you read the problem carefully, you find that they're independent. I'm trying to make our solution here abstracting it from the narrative. Earlier in the year I asked you to look at the narrative. Now I'm asking you to abstract from the narrative in order to find the generality of these methods. The data are follows. We have two sets of data, 1 and 2. For the first set, the sample size is 15. The second sample has size 13. The sample mean for the first sample is 88.9, and for the second sample, the mean is 82.9, and for the first sample, the standard deviation is 32, and for the second, the standard deviation is 32 for the second. Said that wrong. Let's try again. For the second sample, the standard deviation will be 20. Now I have copied the data properly. I proposed to use proposed method. And that is the mean of the sampling distribution of sample differences is equal to mu1 minus mu2, and is approximately equal to x1 bar minus x2 bar well, as long as the samples populations are normally distributed. Data from which we draw the samples. So using that method, we'll make it assume, so this works out, so that the best estimate we have of the sample difference, the point estimate, is x1 bar, 88.9, minus x2 bar, 82.9. Which is equal to 6.0. That's our point estimate of the difference, 6.0.